It's time to try and make a kernel for, in this case, I'm running Fedora. This is Fedora 34. So I tried to make a kernel compile from scratch or source on CentOS 8.3 and didn't have much luck due to a key PEM problem. So this one's running 5.11, and what I want to do is try and get something even a little newer in here just to see how the kernel compilation works these days. So let's do that. I'm going to go to kernel.org. Okay, I'm on kernel.org now, and on kernel.org, 5.12, and this kernel is 5.11. Wow. So these are pretty darn close. But that's enough. Let's see if we can update this thing. So I'm going to copy this link here and download the source. Let's see if wget works. Wget is on here. Okay. Gonna get the kernel source now. Let's get it from here. Don't want that. Let's see. I want this copy link address. There we go. And get the kernel down, the source. Now we're gonna do an xz minus d. Get thing decompressed here. And next we'll do a tar and compress or a tar extract. Tar minus xf, and we'll grab this and untar it. That'll give us the kernel directory files. Let's do that. So I've been trying this on CentOS 8.3, didn't get too far. Let's try it. Whoops, let's try it on this system here on Fedora, which doesn't have Red Hat license problem, I don't think. Okay, now there's our kernel. I'm thinking if I want to do a make menu config first, see what's in the kernel. I should get up yep, it's working. So this is good. This is what we could build with the kernel. If I don't make any changes here, it'll just build what's already here, which is probably what's in the config file anyway. So yeah, this can be interesting to look through here. And you can basically add your own drivers here if you want, if you have one, and you have it in the right format. All sorts of drivers in here. Looks like lots of modules are getting made. File systems is always interesting. So ext is not used anymore. ext4 is compiled into the kernel. And what else? JB2 file system, riser file system. You can get riser as a module, JFS as a module. These two are compiled in. XFS is a loadable module. GFS, wow, that's cool. As modules, kernel space clustering. This would be worth exploring. Never really explored that. Okay, so that is about that. I'm not going to make any changes for the file systems here. Just going to jump out. Kernel hacking. I'm not going to really mess around with this stuff either. So we didn't really save anything. It's just going to be the same old file. Okay, the file's written. I should be able to do a make all, and I think that would go. Make all minus, okay. Check our processors and proc. Yep, we got 4. Make Oh, minus J4. We'll get it going fast. Yeah, it's fast. Holy crap. This runs a lot faster than it ran on Ubuntu or on CentOS 8.3. This is like really wicked fast. So I'm running this on VMware ESXi 6.7 with 4 processors and 2 gigs of memory. This is really running pretty strong for a virtual machine. So trying to build it all here. Yeah, so far so good. Well, that doesn't look too good. Hopefully that doesn't kill us. So it had an error up there. Let's see what happened. We're probably missing something. So building a kernel is not easy. There's always something bad going on. I'm probably not going to be able to fix that. So include Linux fortify string, note, macro, return. That's a warning or an error. Looks like a warning. So I'm not sure what was fatal here. I'm probably missing something. Arch x86 error 2. Wonder if I can just make in here. Nope, 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 can't. So I'm building this thing as, okay, here we go. What's wrong here? Can't find Perl. Are you kidding me? Okay. Uh, the kernel needs Perl. Is that crazy or what? Perl. Looks like it does need Perl. Probably needs Python too. Boy, that pulls in a lot of garbage. Way too much stuff. Looks like it pulled in GCC too. Okay. All right, we got Perl. Yum, install. Let's get this in here too if it's here. Okay, that's already there. Let's do a make all again. It'll pick up where it left off. Well, that looks better. I'm just hoping that it didn't need Perl before. We're going to miss out on some things. So make will always pick up where it leaves off. That's what's great about it. It'll check for files that are compiled, and then it will start looking for dependencies that aren't compiled, and it starts doing compiles on the CC compiles on the C files. So looking good. And let's see how we do. If we're lucky, we can do a make install, and this will be all done. We'll have a new kernel. If it's that easy, it's going to be a miracle. I'm used to moving all the files manually and hacking with Grub or hacking with Lilo, so if we don't have to muck around with Lilo or Grub especially, using Grubby, I'll be happy if this just works. But it's never that easy. All right, it's going along. This took an hour many years ago when I've done this on older kernels. Probably when the kernels were numbered like in the threes and twos, I did this stuff, and it's no different. There was still make xconfig, there was still menu config. It wasn't much different than now. I don't think Linus would change it a whole lot. That's how Linus is. He wants things repeatable. This kernel probably has everything under the tree, from soup to nuts in this thing. A lot of modules here getting made. There's block.io, drivers, phi drivers for cards. I think what I want to have in here is the VMware drivers for VMware. Excuse me. So I must not have been able to build all this stuff on CentOS 8.3 because it didn't seem to take this long. I think I was done by now, so I must have not been able to compile the modules because the PEM error on CentOS 8.3 because it's derived from Red Hat and there's a PEM involved. I'm not sure why it wants a PEM to build a kernel, but that kind of knocked me dead on 8.3, so I punted up here to Fedora 34. I hadn't really used Fedora for a while. It's sassy and fast as usual. Fedora is always a cutting edge. All right, still making drivers here. Sound drivers for every sound card known to mankind. I wonder how fast they can build, say, Windows 10 these days. I wonder how much is involved in that. Of course, I'm building the kernel. I'm not building the applications that Linux uses. I'm not building X Windows or any of the graphical interfaces that go on top of it, nor the applications that go into it. So this is just the kernel. I wonder if we can read something interesting while it's working. Include patch. I wonder if I gotta put patches on here too. What if I don't put a patch on here? What does that mean? Change log. Let's see, tested by these guys here. Hell yeah, they got like 1, 2, 3, 4, 5, 6, 7. Got like 15 testers. NetBridge commit. Let's see what they've done here. Well, they're fixing bugs. ext4. Debug format string warning. Huh. Lots of ext kernel test robot. Look at that at intel.com. That's pretty cool. That is really cool. So Intel itself is doing regression testing on this thing, on Fedora. And our friends at China are working on it. Pretty neat. All right, it's still going. Falcon board, whatever that is. What is that? V3U. Okay. Boy, a lot of notes here, huh? They got some dumps in there. These guys do a lot of fixing in one release. It's pretty comprehensive. An idle core is present in the LLC of target CPU. Still going. Okay, let's look for something interesting here. Spin lock testing. Array index out of bounds. Some guy in France. How are we doing here? We're still going. Okay. Well, it's amazing how much quality goes into this kernel. 15 testers. They're working pretty hard. Still going. Some guy in Russia working on it. It's cool. It's like worldwide contributions. That's how it should be. I bet each one of these testers is good at a part of the kernel that they're responsible for. So they have patches out already for the kernel. Still going. This one's EOL. Interesting. Still going. A tainted kernel. Still going. Look at that. Is sys now native in the kernel? Maybe, huh? So it's a module now. SMB3 module. That's pretty cool. Build instructions. Download the kernel. Make menu config, select sys from the network file system. That's all you do. So I guess you don't need Samba anymore. That's pretty cool. That's amazing. Oh, it's still going. Huh. Look how cool that is. That's pretty cool. I wonder when they put that in there. That is really cool. Everything's kind of merging together. Now Windows 10 can run Ubuntu. So Linux is running Windows protocols and Windows is running Linux containers with Ubuntu in it. Binary kernel support. IBM's JFS. Look at what's all this all about. JFS. JFS. Okay. It's still going. JFS. Laptop drivers. Asus laptops. LG laptops. Of course, there's laptop drivers. Module signing. Namespaces. Still going. Maybe this will take an hour. You must compile serial support into the kernel and not as a module. That's pretty cool. That's old style. That's like running a really old computer with a serial port on a UART. Well, that was a warning that went by. So we're still alive. This is pretty cool stuff. So you could run a Linux kernel in a VT100 terminal if you compile in the console with a UART. Do computers have UARTs in them anymore? I don't think so. You need a virtual UART. So I guess you could put a UART through USB 2 or something. Convert that to RS-232. Kconfig language. Options in a tree structure. Okay, it's still going. Firmware documentation. That's interesting. Firmware. LEDs. Kernel licensing. This is neat. Harassment through experience. Does Linus understand this? Does Linus understand that? Body size. So anyone who's overweight gets yelled at. Somebody must have got yelled at. Welcoming and inclusive language. Respectful. Graceful. They have an enforcement committee. Well, what does this mean? Looks like that's all the developers of the kernel. Deprecated features. It's still chugging away, people. Maybe it will take an hour. This is pretty cool. Okay. They have a lot of guides here. F-trace, K-probe, event tracing. NMI tracer for non-maskable interrupts, trace hub. Intel trace hub. Interesting. Driver model. Pretty cool. Binding bus. Okay. Bus type. Still going. Design patterns. Driver structure, parent name, bus. Yeah, looks about right. Devices, intro. DMA. DMA, I squared C, IIO, input. PCI. Boy, that hasn't changed, has it? That's kind of good, it hasn't changed. That means they designed it right in the first place. And it's still going. So obviously there's thousands of modules to worry about. Thousands of modules. Oh, something went by bad. Porting to the new driver model. The new driver model, that's not very new. That's pretty cool. Still going. All right. That's amazing. They run this thing on IBM too. Old S390. That's an old system. That's crazy old. So IBM paid money to make this work. Super H, Spark, Sun, x86. What the heck is this? Still going. Yeah, this is probably why this took an hour last time. It just has way too many devices, so I probably should have disabled a lot of the stuff. These are all modules, so they're ready to go. They're needed, but most will not be used. As I recall, the modules are what took all the time in this. Back when I used to build kernels, it's now coming back to me how long this took. I guess I thought things were speedier these days, but they're not. So hopefully once this stuff is all compiled, if you make a change, it should be able to skip over this stuff, I would think, pretty fast. Because right now we're still getting our KOs built. This thing is building every old wireless card known to mankind. Okay, it looks like we hit an error here. That's a really arcane error too. Couldn't make the BTF. So that's it for tonight. I'm not going to bother debugging this tonight. Looks like it got close to generating this. Let's see if I can do that. Actually, let's give it some more processors to work with. There we go. Oh, that looks promising. Oh, I'm still hitting that issue, so I think it's going to be a job for tomorrow morning. Okay, well, thanks for watching. This is a fail in this kernel build, but we did get a long way into it. I appreciate your kind attention and have a great day.